Hey there everybody, Mr. Dickin here. In this video we are going to be starting a new unit, Unit 3. We went ahead and we split Unit 3 into two halves just because it does cover a lot of content. So we're going to have 3A and then, you guessed it later on, we'll have Unit 3B. With the Unit 3A, just as a heads up, it's going to be very short. So there's only going to be 7 videos, or 7 lessons I should say. I might add some additional supplemental videos, but it's going to go by pretty quick, and the whole purpose is to introduce what we know about quadratics. All right, so let's get talking here. Quadratics, by definition, a quadratic, and we already kind of know this from our parent functions, is any time you have an x squared, with that being the highest degree variable, and those will create graphs that kind of look like U-shapes. We're going to call those parabolas. So this unit, what we're going to learn how to do is figure out all the key features of a parabola. So we're going to learn how to find, maybe the x-intercepts. We'll figure out what's going on there. We'll discuss what we can figure out about the vertex. And along with the vertex comes kind of like that centerline axis of symmetry. So that's all the information that we're going to be discussing throughout Unit 3. All right, so let's get going, shall we? What I want you guys to do, by the way, this is a worksheet that I'll put a PDF online of. So I want you guys to grab your calculators and throw each one of these functions into your y1, y2, and y3. And when you do this, please make sure that you have your zoom set to zoom standard, okay? And that just makes sure your window is going to be showing the same thing as the graph I'm about to show you. So we have 3 different functions, y1, y2, y3. Plug those into your calculator. And this is the graph that you should see from those functions. Now you might notice, hey, what the heck? We did 3 different functions, yet I see one single graph. What the H, Mr. D? What's going on here? Well, surprise, surprise, all of these 3 graphs create the exact same function. And if I really wanted to, I could go through and like y1, I could distribute this x minus 3 and the x plus 1, and it's going to look the exact same as y2, this x squared minus 2x minus 3. Heck, I could even do that with y3, because that x minus 1 is really an x minus 1 times another x minus 1. So I could distribute that out, and then I have the minus 4 at the end, and that would also simplify to be the y2. So here we're seeing how all 3 different functions can kind of produce one graph. Now we're going to digest some pieces of the graph here and maybe figure out how we could reverse engineer some information from these functions based on that. So let's take a look at the graph. What do I know? Well, I'm seeing it hits the x-axis at 2 spots. So -1, 0, and then 3, 0. So I have 2 x-intercepts there at -1 and +3. I've got a y-intercept here at 0, -3. Then I've got my vertex. This is going to be at 1, -4. And remember, with the vertex, that also kind of tells us what's going to be called the axis of symmetry, which is kind of a line that splits our parabola in half, so everything that's on the left side of that line mirrors on the right side as well. So these are just some visual things that I'm picking up on right now. So now let's go through and see what questions are being asked. All right, coordinates of the vertex. Well, the vertex is this point right here, so that was 1, -4. And then it's going to ask, all right, which equation was that most easily determined from? So I've got 1, -4. Let's see if I can steal that. 1, -4. Which of those equations do I see 1s and 4s? It looks like equation C. Right, if I look at my function, I see a 1 there and I see a -4 there. Lo and behold, 1, boom, -4, boom. Now some of you might be saying, but hey, Mr. D, that's a -1. What gives, bro? We'll discuss that in a little bit. All right, so that was determined from equation C. And we know that, hey, there's a horizontal shift to the right 1 and a vertical shift is down 4. So remember when we had our parent functions, we have a -1 inside of a function and a -4. The -1 inside shifts it to the right, a -4 on the outside shifts it down. So hey, that starts to make a little bit more sense, right? Let's see, the y-intercept, that was this guy right here. So we already found that. So that was 0, -3. 0, -3. Do any of my functions have a 0 and a -3? Huh. I'm seeing a -3 here on equation A, but also I'm seeing a -3 at the end of equation B, so that one could kind of go for either. Well, maybe let's reverse engineer this a bit. If my x value is 0, that means my y value is -3. If I plugged in 0 for x, 0 minus 3, -3, times 0 plus 1, 1. -3 times 1, crazy, okay. If I plugged in 0 over here for b, 0 squared is 0 minus 2 times 0 is still 0, 0 minus 3, also -3. Interesting, interesting, interesting. Let's see what we have to say. So we're going to actually use equation B for this one, because by plugging in 0 for x, these two terms would cancel out. You're left with a -3 there. Okay, next. Coordinates of the x-intercepts. So right here where it says x-intercepts, you're going to hear me call those zeros a lot. So x-intercepts, I'll call those zeros. They're also called solutions or roots, just as a little heads up. Our x-intercepts were these guys right here at -1 and +3. And process of elimination, that can be gathered from equation A. And if I look at what equation A was saying, we have the quantity x minus 3 and x plus 1. Well, these values are just the opposites of what's appearing in there. All right, cool. So let's formalize some stuff here. There are going to be 3 forms that we're going to be expected to know. There's going to be factored form, or x-intercept form, standard form, and vertex form. Standard form is going to be most popular when it comes to word problems. Factored form, we don't really see a whole lot given to us. Later down the road, we're going to have to throw things into factored form. And then we have vertex form. Me personally, I think factored form is my personal favorite, but that's just me. All right, so let's get into what each one of these looks like. Factored form is going to be y equals x minus p times x minus q, and that's going to have a coefficient out front of an a value. Now with intercept form, that's not what I wanted to do. With intercept form, the numbers that are in place here, those are going to tell you your x-intercepts. Now important to note here, this minus sign is built into the function. So you're going to have to kind of do reverse logic when you see a value there. So I'm just making up an equation here. If I had x minus 7 and x plus 4, my x-intercepts would be at 7, positive 7, comma 0, and then negative 4, comma 0. So it's always going to be the opposite of what you would think, all right? Standard form is going to be y equals, or f of x equals, ax squared plus bx plus c. Now with standard form, the a value is going to be the same a value that you would have had in factored or intercept form. But what's really good about standard form is the C value. And that C value is going to tell us our y-intercept. So our y-intercept is going to be 0, comma, whatever that C value is. And the reason for that is if I plugged in 0 for x, 0 squared is 0, so this whole term would be 0. 0 times whatever b is still going to be 0. So these two terms are going to basically be ignored, right? They're just 0, and then I'm left with the c value at the end, and that's going to be our y-intercept. So standard form is going to tell us y-intercept. Intercept form will tell us x-intercepts, or factored form will tell us x-intercepts. And then there's vertex form. Man, I wonder what vertex form would tell me. Well, if you're thinking ahead, it's going to tell us the vertex. Yay. So vertex form is going to be written as y equals a times x minus h, quantity squared, plus k. Now this a value is going to be the same a value that we saw in previous ones. And down the road we're going to learn more about it, but if you think back to parent functions, that just tells us, is it going to open up or open down, positive or negative, and do we stretch or shrink it? So that's really all it's going to say. But then we have these h and k values. Well, that's going to tell us the coordinates of the vertex. So our vertex is going to be at h, comma, k. Now one thing that you guys will need to be aware of is your h value is always going to be the opposite of what you would naturally think. So if you have x minus, say, 5, this would be a positive 5 here. If you had x plus 3, this would be a negative 3 here. So that's going to behave the same way as what we saw above with the intercept form. All right, so those are the three formats that we can write equations in. With all of these, they each have their own little individual strength. And then we'd have to do a little bit extra work to find the other tidbits of info. Because remember, when we're talking about quadratics, there's only a few things I can ask you. X-intercepts, y-intercept, vertex. That's about it. All right, so let's see the questions that were asked on the flip side of that worksheet. All right. We want to write an equation that has a vertex at -2, -5. Well, if we're given the vertex, I'm thinking, hey, let's use vertex form, shall we? So with vertex form, I can choose any a value I want. It doesn't matter which one or what I choose for a. So I'm just not going to choose one at all. I'll just pretend it's 1. And I can plug in, so x minus -2 would be x plus 2. Remember, these are going to be the opposites, the x values. Quantity squared with a -5 outside. A y-intercept is given. Well, if I have a y-intercept, chances are I'm going to want to deal with standard form. So I just need to have some equation written in standard form, and it better have a 6 at the end of it. There we go. X squared plus 6. There are infinitely many correct answers for this, I should mention. You could have 13x squared minus 48x plus 6. You could have 8,000,002 x squared plus 6. It doesn't matter, as long as the plus 6 is your constant term. Here we're given x-intercepts at +3 and +5. If we're given the intercepts, we're going to want to use intercept or factored form. So you'll notice we have an x minus 3 and an x minus 5. The reason for that, right, if I had 3 as an x value, if I plug that in, 3 minus 3 is 0. 0 times whatever this is, doesn't matter, it's going to be 0. So by plugging in 3 for x, my y value results in a 0. Boom, I get a point, 3, 0. Same thing goes for this x minus 5 factor there. And last one, x-intercepts. So it's going to behave the exact same as c. At the origin and for 0. Well, if it's at the origin, that's the point 0, 0. So this is what that function might look like. I should make note right here. If you wrote x minus 0, that's still the same thing. That's still correct. Heck, you could even write x plus 0. It doesn't matter. As long as you just had a plain old x. That's all we care about. And with all of these, just as a reminder as well, Your A value, so the number that would be out here, it could be anything you want, and it's not going to change the vertex or y-intercept or x-intercepts for all of these functions, all right? So if I put a 17 out front of this whole thing, it's still going to have a vertex of -2, -5. If I plug a -48 in front of here, it's still going to have a y-intercept of 6, as long as these pieces hold true. All right, let's carry on. So number 5 says the profit that a company makes selling an item in thousands of dollars, so they're telling us our units, depends on the price of an item. All right, if you charge more money, you're going to make more profit. I would assume if you charge too much, people might not want to buy it, so maybe profit could drop. Whoops. So here we're given 3 different forms of the same function. All right, so these functions are all the exact same. You'll notice they all have the exact same A value, so that's going to hold true throughout. And we're asked a few questions. Now, as I'm looking through, just by gathering some information here, I know that we're going to have a y-intercept at -54, because standard form tells me a y-intercept at -54. I'm going to have x-intercepts at 3 and 9. And then my vertex is going to be at 6, 18. All right, so I'm just going to go through and kind of jot down what each piece of information has given me. So we have, we have our y-intercept as 0 and -54. We've got our x-intercepts at 3, 0 and 9, 0. Let me put a space in between there. And then we have 6, 18 as our vertex. All right. So that's just kind of keeping some information straight there. All right, so what are the prices that would give a profit of $0? Well, if it's saying $0, that would be something, 0, because my y value here is talking about profits. Well, that indicates to me I'm looking for my x-intercepts. So what are the x-intercepts of this thing? Oh, hey, we already found that. That was 3 and 9. So if I were to solve this thing out, right, by plugging 0 for the profit, we could easily solve this equation, because it's already in factored form, by getting what number minus 3 gives me 0, what number minus 9 gives me 0. What is the profit when the price is 0? So it tells me I'm charging $0. So I'm going to plug 0 in for x. What's the profit that would result from that? So it's going to be x, not x, 0, something. Well, 0, something, that's going to be my y-intercept. And we already know the y-intercept. We found that from our standard form equation. So our profit would be -$54. So we would actually be losing money, right? Or sorry, not -$54, -$54,000. So we're losing money, which makes sense. If you have a product and you're giving it away for free, you're going to lose all of the money that you spent making whatever product that was. All right, what is the price that gives the maximum profit? Maximum. So if I think of this parabola, the maximum point is going to be the very highest value that it reaches. Well, that is just going to be our vertex. So that value there is just going to be our vertex. Now, our vertex gives me 2 pieces, though, 6 and 18. So I need to know what price gives the maximum profit. So which of these 2 numbers represents price? Well, that's going to be the x value. So my x value here is 6. Charging $6 would give me my maximum profit. What is said maximum profit? So which of these 2 numbers from our vertex would be the maximum profit? Profit's the Y value. So that'd be 18. But remember, we're in thousands of dollars, so $18,000. All right. So that was a overarching introduction to quadratic functions. If you felt overwhelmed by this video, we're going to be breaking down each individual topic that I talked about in future lessons and future videos, so please don't fret just yet. And as always, folks, you know the drill. If you have any questions, please let me know. And good luck, have fun, be safe, roll tide.